Okay, we're going to look at 6.3 vectors. So what is a vector? A vector is a directed line segment. Okay, so could look like, a line with an arrow. It's actually really a ray, and the arrow denotes the direction of the line segment. Okay, so the direction, if I have a ray that looks like this, if I were to draw a horizontal line here, the direction would be the angle from the horizontal line to the ray. So it's theta. We know from trig that I can find theta by figuring out using the tangent. So the tangent of theta is equal to y over x, or the inverse tangent of y over x is equal to theta. So that's how we find the direction of the ray. The magnitude is the length of the ray, or the line segment. Okay, so we can figure out the length of the ray by saying, we're taking the square root of x squared plus y squared, and that's going to equal the magnitude. We show magnitude by these double, like what look like absolute value signs, and then we do like a bolded out letter for the vector, or you can put a little arrow on the top. Okay, so a vector is it's a bold letter, or a letter with arrow. Okay. Let's talk about standard position. So the standard position for a vector is right at the origin. So if I draw my vector with the center or the starting point at the origin, origin. Okay. Let me see. So something else that is important about a vector is that the point that it starts from is called the initial point, and the ending point at the arrow doesn't say it goes on forever. It's just denotes the direction. Okay, so the ending point is called the terminal point. So you'll see a lot of that terminology as you read through the directions for your vectors. So back to the standard position, if I have a vector in a standard position, it starts at the origin and then goes out from there. Okay, so that's going to be our standard position. So we can say that a vector is in its component form. Sometimes they say it's a rectangular form when we're talking in terms of x and y. So uses x and y. So we, instead of parentheses, we're going to do, let's say I have a vector, vector here, and we're moving some change in x this way, and then some change in y this way. Our component form would be the change in x, comma, change in y. So how far over to the left or right I move, and then up or down. And we use pointy brackets to denote a vector. Okay, so equivalent vectors. here's the deal. Vectors can be can have the same magnitude, so length, magnitude, and direction, but be in a different location. So for example, say I got this coordinate plane here. I'm going to make a vector v that is comprised of 2 in the x direction and -3 in the y direction. Okay, so I'm going to move, and my initial point is going to be at right here. Okay, I'm going to move 2 in the right because that's the x, 1, 2, and 3 down, 1, 2, 3. So my terminal point will be right there. And this is the size and the direction of vector v. Well, I can also have another vector. Say I start from this point. I can still move 2, 1, 2, down 1, 2, 3. And this vector is also vector v. It's the same size and it's in the same direction, pointing in the same direction. So it is an equivalent vector, just in a different spot. I can make one at the origin in standard position. Okay, this is vector v. These are all the same. So where it is on the coordinate plane, it doesn't matter. It's all about just where the magnitude and the direction. Okay, a unit vector. A unit vector is a vector with a length of 1. Vector with magnitude equal to 1. Okay, so like these two vectors are here, the standard unit I vector and the standard unit j vector. These both have a magnitude of 1 because they are a unit vector. A unit vector. Okay, so the I vector is going in the horizontal direction. The j vector is going straight up in the vertical direction. So, a unit vector I is going straight horizontally. So I'm going to go ahead and just start from the center, 0, 0, and I'm going to move out 1 unit. That is vector I is 1 unit. Plus another I. That would be 2 I's. Another I. 3 I. These are all 1 unit in magnitude. Okay. The j vector, it goes straight up. So 1 j vector would be like that. Another j vector. Another j vector. Okay, so that's the positive j vector and the positive I vector. Let's do a couple examples now. All right, so graph the vector v with initial point q at -1, 2, so a point because it has parentheses instead of pointy parentheses, and a terminal point of p at 4, -7. So the name of our vector is v, and we're going to go to -1, +2. Okay, that's my initial point. And then our point P is at 1, 2, 3, 4, 5, 6, 7. Okay. And since this is a directed line segment, it's going to go from the initial to the terminal. It's really important, and it gets an arrow. Okay, and this is vector V. So I'm also going to graph this vector in standard position. So let's go ahead and change the color. This is going to overlay on top. So this vector is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is -9 in the y direction, and 1, 2, 3, 4, 5. So it's positive in the x direction. So I can actually, let's write this in component form first. So we write it as the change in x, and the change in y. So the change in x was 5, and the change in y was -9. It's kind of like slope, okay? So if I were to write this vector in the standard position, I would start here, and I would just go ahead and count 1, 2, 3, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. And it looks like I'm going to end up right there. It's just a little bit longer. Okay, starts a little further. Next, what is the vector as a linear combination? So a linear combination means that we're going to write our vector as using our standard unit vectors. Okay. So what we say is it's the change in x times the I vector plus the change in y times the j vector. Remember, I is horizontal and j is vertical. So I can go ahead and I'm going to redraw this over here. Back to my original vector. It doesn't really matter where it's laying. 5. So in order to get from my initial point to my terminal point, I can move over horizontally 1 unit, 2 units, 3, 4, 5 in the I direction. So I would have 5I, and in the y direction, 1, 2, 3, 9. This would be, since the vectors are going downwards, this would be -9j vectors. Okay, so each j vector is 1 unit. So I'm going to write this as 5i plus -9j, or -9j. All right, so another thing we have to do is find the magnitude of vector v. So we write it like this. The magnitude of vector v, the double lines equal the magnitude. And we basically use the distance formula or Pythagorean theorem. So the square root of the change in x squared plus the change in y squared. So vector v is equal to 5 squared plus -9 squared. And that gives me the absolute value of v is equal to the square root of 25 plus 81, which is 106. So the absolute value of 106 is the length of my vector. Now we're going to go ahead and look at the direction. So in order to figure out the direction here, okay, we're going to have the tangent inverse of y over x, so -9/5 is equal to, and we're going to do this in degrees right now, just for fun. Okay. Inverse tan -9/5 is -60.94 degrees. Well, it rounds to 9.5. All right, so that is our first example. Let's do another video for vector operations.